Most beginners imagine computers as constantly working machines, fans spinning, screens glowing, numbers flying. So the assumption becomes if the computer is on, something must be happening. That assumption is wrong, and it quietly breaks how people understand software. A computer can be powered on, fully awake, and doing absolutely nothing meaningful. No execution, no decisions, no progress. This misunderstanding is where confusion begins later, when people expect programs to just run or data to just update. Before we talk about programming, we need to fix this mental model. Electricity doesn't create behavior, it only makes behavior possible. Think of power as permission, not instruction. The system doesn't start doing things just because it can, it waits. Waiting is not a failure state, waiting is the default state. This matters because software doesn't exist in a constant flow. Execution only begins when something explicitly triggers it. No trigger means no execution, even if everything is powered and ready. Even when something can run, it doesn't necessarily run. Every system decides what runs, when it runs, and what must wait. Your software never owns the machine. It requests time. This is why execution feels unpredictable to beginners. They imagine programs as self-driven. In reality, execution is borrowed time, and most of the time, your program is waiting, not running. Another common mistake is treating memory like a brain. Memory doesn't think, it doesn't plan, it doesn't remember anything by itself. Memory is just a workspace, a place where values sit. Nothing happens in memory unless execution touches it. No reading, no writing, no change. This separation is critical. Memory holds state. Execution creates motion. If you blur those roles, bugs become difficult to find because you'll expect data to act on its own. A program can exist perfectly and never run. Being written doesn't mean being executed. Being stored doesn't mean being active. Until execution begins, software is inert. It has no behavior. It produces no effects. This is why asking, what does this code do? Is often the wrong question. The real question is, when does this run and when does it not run? Execution isn't a thing you can point to. You can't open a folder and find execution inside. You can't store it. You can't save it. Execution only exists while it's happening. When it ends, it's gone. All that remains is state, the leftovers. This is why tracking execution paths matters more than reading code. The path defines what actually happened. When people struggle with programming later, it's rarely syntax, it's assumptions. Assuming something ran, assuming something updated, assuming something was active. But systems don't assume, they execute, or they don't. Once you stop imagining constant activity, systems are simple to understand, and predictability is what makes software reliable.